4.2 is introducing permutations and factorial notation. So what we're going to do is use factorial notation to solve simple permutation problems. And permutation, by definition here, is just an arrangement of distinguishable objects in a definite order. So what that's saying is you have like socks and shoes, two distinguishable objects, and you're putting them away in your closet, and they have to go in a specific order. Maybe you've got OCD and you need to have, you know, certain color socks together and then certain color shoes together, or whatever it is. So it says, for example, the objects A and B have two permutations. I can range them in AB or BA. Okay, so if I have red sock, blue sock, I can go red sock, blue sock, or blue sock, red sock. So that's all it is. Permutation is a way of arranging distinct objects in a particular order. Factorial notation then is a concise representation of the product of consecutive descending natural numbers. Okay, so when we talk about factorial notation, we're taking a natural number and then we're doing the product of the numbers from that number to the number that goes after it. So for example, 1 factorial means that I'm just multiplying 1, or it's just 1. 2 factorial, then I start at 2 and I go 2 times 1. 3 factorial would be 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. So it's a concise representation of the product of consecutive descending natural numbers. When we're talking factorial, we're never using decimals or irrational numbers or rational numbers. It's always natural numbers. So if you have a question that says n factorial, then that means you're starting at n and you're going in descending order. So you're starting at n and then n minus 1, n minus 2, and depending what n was, eventually what you're going to do is end up at 3 times 2 times 1. Okay? And we'll be using this n factorial to solve some problems a little later on. So it says, Naomi volunteers after school at a daycare center in Whitehorse, Yukon. Each afternoon around 4 p.m. she lines up her group of children at the water fountain to get a drink of water. How many different arrangements of 6 children can Naomi create for the lineup for the water fountain if there are 6 children in her group? So to figure this out pictorially, if you want to call it that, if we call our children A, B, C, D, E, and F. So she could arrange them just like that. Or she could move them around. Let's say she starts with A, but she moves B to the end. So C, D, E, F, B. So who's ever second is always going to go into last position. So A, D, E, F, B, C. A, E, F, B, C, D, and then she'd have A, F, B, C, D, E. Now that's just moving the second position around. Then, because then she can move the 3rd position person around, and she can move the 4th position around. So as you can see, just like what we talked about in the last section, sometimes it's just too much work to do this with pictures or with symbols, or what we called it in the last section was doing a factor tree or the diagrams. So you can use math instead to figure this out. So this is way too much work. If you have to go through and list all if you have to go through and list all of the different arrangements that you have. Okay. So let's do this using math. So we determine the number of arrangements that 6 children can form while lining up to get a drink. So in position A, so you have 6 choices to go into this first position. And I shouldn't have used A. This should actually be 1, 2, 3, because we called our kids A, B, C, D, E, and F. 1, 2, 3, whoops, 4, 5, 6. So as long as you don't confuse that position A as meaning person A, you don't need to change them. So for this, for position A, we would have 6 people in there. Once that person is in a spot, that means we have one less to go into position 2. And same thing then, position 3, well, we've used 2 people, so we're left with 4. Position 4, we've used 3 people, so we're left with 3. Position 2, we've used 4 people, so we're left with 2. Sorry, position 5. Position 6, we've used everybody but one person. So if we let L, and I don't know why I picked L, but we'll just use it. If we let L represent the total number of permutations, and I'm just going to write them as perms, then L is equal to 6 times 5 times 4 times 3 times 2 times 1. By definition then, when we have a natural number that we are writing in descending order and it's the product of them, so this then is actually the same as saying it's a factorial notation, or we can put it in factorial notation by saying that this is 6 factorial. So if you multiply 6 times 5 gives you 30, times 4 is 120, times 3 is 360, times 2 is 720. So that means there are 720 ways that the 6 children can be arranged to go to the water fountain. Because this is a problem solving, you should always answer with a sentence. So to go to the fountain. Okay. So it says example 2, evaluating numerical expressions involving factorial notations. We're going to evaluate the following. So 10 factorial then is the same as 10 times 9 times 8 times 7 times 6 times 5, 4, 3, 2, and 1. So if you multiply all of that together on your calculator, you get 3,268,000. Sorry, 3,628,000. Little dyslexia there. 800. If I have 12 factorial divided by 9 factorial times 3 factorial. So I just write these out. And put that all over 9 times 8 times 7 times 6, 4, 3, 2, and 1, and then times 3 times 2 times 1. So really, I mean, I wrote it all out, but if I take a look at this, my 987654321 is exactly the same as this. So really, those two can cancel each other out. So what I'm left with then is 12 times 11 times 10 over 3 times 2 times 1. So my answer then is going to be 220 factorial. And there's, or 220, not factorial. There's a few different ways that you could solve this. This is just one way. Another way would be to say that I've got, okay, 12 times 11 times 10, and then divide my 3 times 2 times 1. I could have divided that down a little bit on the top before I even did the multiplying. What you're going to find is this becomes a lot of work to do. Some questions are going to ask you to expand it, so you'll have to write them out like that, but a lot of times you can just do this on your calculator. So what I want to show you then is on your calculators, and I'm not going to be able to show you because I can't bring up my emulator, but I'm going to tell you on your calculators, on your graphing calculators. If you go into the math button, and the math button is the third button on the left underneath the green alpha. So we want to do math. And then the next button we want is across the top there. The math is highlighted, and there's num, CPX, and PRB. If you hit the left arrow, it's going to put you on PRB, which stands for probability. From there, then, what we want to do is the factorial button. So that is number 4. So 4 gets you the factorial. And then if we were actually solving, then what we would do is just hit the enter, and it would give us what it looks like, and then your answer. So let's try this for 10 factorial. So on your calculators then, put your 10. So to solve this one here, oops, that's a really bad arrow. First thing we're going to do is put in a 10. Then hit our math, left arrow. Then we go down to 4. And on your screen pops up 10 factorial. Okay, so right here after I do that, I have 10 factorial flashing on my screen, or sorry, not flashing, but 10 factorial with a cursor flashing behind it. Hit enter, and you get your answer. Okay, so that's just a quicker way of doing it. When you're doing this for a question like this one where you have divide, you have to remember wherever this divide sign is, we're going to throw in a bracket right after that. So on your calculator, you would do your 12 math, left arrow, 4, excuse me, 12 math, left arrow, 4. Then you put your divide, and then a bracket. And if you don't put a bracket, then what it's going to do is it will solve for you 12 factorial divided by 9 factorial times 3 factorial, which isn't the same. We want it to be 9 factorial times 3 factorial. So you have to have that bracket in there. So I do my 9 math, left arrow, 4 times 3 math, left arrow, 4 bracket, and then enter, and I get my 220. You can try it for doing it this way without the brackets and see that it changes your answer quite drastically. Okay? So whenever you have the divide, make sure whatever is in the denominator is in a bracket, otherwise you get a different answer. Okay. So 0 factorial is defined to be equal to 1. And there's a proof for it, but we're not going to bother with a proof for it. Just believe me that 0 factorial is always going to be equal to 1. Restrictions. We worked a lot with restrictions in your math courses. Restrictions usually have to deal, or always have to deal, with what's in your denominator. So we're going to look at restrictions on n if n factorial is defined. And you'll see once we get into some numbers here, remember it has to be a natural number. So if you have a negative value, you can't do the factorial of it. I can't do the factorial of -7. If you do that on your calculator, it'll give you an error. So if n is defined, then you can find restrictions on it. It says, for example, state the values of n for which each expression is defined, where n is an element of integers. So if I look at this one, n minus 3, we're looking for the restrictions on this. So I take what's inside here, n minus 3, put it greater than equal to 0 because my n can't be a negative number, or it can't equal a negative value, sorry. I could have a negative number in there because I could have, no, can I? I'm just trying to think. Anyway, you solve for n to see what the restriction is. So that means n has to be greater than or equal to 3. So I can solve for this as long as my n value is greater than 3. So what about n factorial divided by n minus 2 factorial? So on the top here, I've got n is greater than or equal to 0, so that's going to work. On the bottom, n minus 2 greater than or equal to 0, so n has to be greater than or equal to 2. So what you need to do when you're in a situation like this, and this is where it's a little bit different than restrictions on rationals or rational numbers or rational expressions, is that you have to find the restriction for the top and the bottom. So if I have n factorial, that n has to be greater than or equal to 0 because I can't do negative values. N minus 2 means that I have to have greater than or equal to 2. So my restriction on this particular expression is whichever value is largest. So choose the biggest as your restriction. So that means for this particular expression, n has to be everything greater than or equal to 2. One thing that is necessary, that you need to keep in mind, is you only need to find a restriction if it's asking you to solve. If it's just saying simplify, you don't need to have a restriction. But if you have to solve, then you have to have a restriction. Okay? So maybe just make that little note here. You only need to find restrictions if you are solving an expression. Okay, so if you're solving for n or whatever the variable is, you need to find the restriction. If you're simplifying, then you don't need to. So example 3 says, simplify an algebraic expression involving factorial notation. Simplify where n is an element of natural numbers. So because this is simplify, that means we have, that should be don't, don't need to find restrictions. Okay, so n plus 3 times n plus 2 factorial. So n, that is equal to n plus 3 times this factorial is only applied to this. If I had a bracket, I'll just draw in my bracket. If my brackets were like that, then it would apply to both of them. But because it's only on the back part there, it only applies to the n plus 2. So n plus 2, if we expand that, is the same as n plus 2 times n plus 1 times n, and then be n minus 1, and then we could continue n minus 2, n minus 3, till we get to 3 times 2 times 1. So your answer for this then is actually, because you're going from n plus 3 to n plus 2, so it's going down in that descending order. So your answer for this one would be n plus 3 factorial. Okay, to simplify this one, n plus 1 factorial over n minus 1 factorial. So if I expand the top, this is n plus 1 times n minus 1 factorial. As soon as your numerator matches your denominator, you stop, because what I have now then is n minus 1 factorial on the top, and I have a multiple of n minus 1 factorial on the bottom too, so those two will just cancel each other out. So this is equal to n plus 1 times n, which is just n squared plus n. Okay, so there'll be a few questions like this when you're working on them, and that's what you have to keep in mind. You expand it, you expand your numerator as far as you have to until it matches what's in the denominator, and then you can cancel numerator and denominator. Okay, example 4 is solving an equation involving factorial notation. So we're solving n factorial over n minus 2 factorial is equal to 90, where n is an element of integers. Now, because this is solving, that means that we have to find the restriction. So n is greater than equal to 0, and then we have n minus 2 greater than equal to 0. So n is greater than equal to 2. So that is my restriction. And just putting a box under it is good enough, or box around it. That works. So now what we need to do is we have to do some expanding here. So on the top I have n factorial. So that's the same as n times n minus 1 times n minus 2 factorial. Now I've got the exact same in the numerator as the denominator. So I have n times n minus 1 times n minus 2 factorial all over n minus 2 factorial, and that is equal to 90. So this and this can cancel. So I'm left with n times n minus 1, so that's n squared minus n is equal to 90. So now to solve this, that means I bring everything over to one side, let my equation equal to 0. So n squared minus n minus 90 is equal to 0. So this is one of my solving types, so I have to figure out which kind it is, product and sum. So I need something to multiply to give me negative 90 and add to give me negative 1. So 9 and 10 will work, with 10 being the negative. N minus 10, n plus 9 is equal to 0. So n minus 10 equals 0, n plus 9 equals 0. N equals 10, n is equal to negative 9. So I have n is equal to negative 9. I can't have a negative value for my factorial, so that means that this is an extraneous root. Well, let's see if my pen catches up. Might have to write that again. Yep, okay. It's an x. Ooh. Extraneous root. So that means my solution for this is n is equal to 10. And always a good idea to put a box around what your final solutions or your final restrictions are. And you can check n is equal to 10 fits into my restriction because 10 is greater than 2. Okay, we solved this one using factoring, but you're going to come across some. I just want to see if I have an extra page in here, and oh, I did. Okay, so you must have that too, I'm assuming. You're going to come across some equations that you can't factor. You can't use slide and divide. It's not a difference of square. It's not product and sum. So then you want to use the quadratic formula, and we've used the quadratic formula before, both in Foundations 20, Pre-Calc 20, and Pre-Calc 30. We used it a little bit as well. So method 2, when factoring is failing you or factoring is just taking too much time, use the quadratic formula. So, quadratic formula is n or x, doesn't matter. N is equal to negative b plus or minus square root b squared minus 4ac all over 2a. b squared minus 4ac is called the discriminant. So one thing you can do before you even start putting this in here is just to substitute your a, b, and c values into there, and if it's a perfect square, then it can be solved. If it's not, then that means there's no solution for this. Okay? So my equation was n squared minus n minus 90 equals 0. So that means A is 1, B is negative 1, C is negative 90. So I substitute into my quadratic formula. So I have n is equal to negative 1 plus or minus negative 1 squared minus 4 times 1 times negative 90 all over 2 times 1. So this is 1 plus or minus 1 squared minus 4 times 1 times negative 90 is 361 all over 2. So n is equal to square root of 361 happens to be a perfect square, which is 19 over 2. So now is when you have your solutions. You have your you have your two solutions you need to solve for. So I have n is equal to 1 plus 19 divided by 2, and n is equal to 1 minus 19 divided by 2. So this n is 20 divided by 2 is 10. This one is negative 18 divided by 2, which is negative 9. So you can see I got the same values, just without factoring. That one, of course, is still extraneous. So n is equal to 10 is still my solution. Okay, so just another option for you for finding that solution. So your key ideas. Permutation is an arrangement of objects in a definite order. So when you have to have certain things in an order, then that's when you have a permutation. Each object appears only once in each arrangement. For example, the set of 3 objects ABC can be listed in 6 different ordered arrangements, and here they are. So you can have ABC, ACB, BAC, BCA, CAB, CBA, and those are the only ways that those 3 letters can be arranged. It says the expression n factorial is called n factorial and represents the number of permutations of a set of different objects and is calculated as n times n minus 1 times n minus 2 till you get down to times 3 times 2 times 1. So the last part, and I need to know the expression n factorial, the variable n is defined only for values that belong to the set of natural numbers. So they have to start at 1, they can't be less than 1, and they are never negative. So that's it for this section. There's your questions to work on. Good luck.